Welcome to this segment. We're solving Math 1100 Tutorial Sheet 2 2026. So we're going to solve all these questions. If you're new to this channel, kindly subscribe and don't forget to like this video. So let's start with the first question. So the first question says express each of the following numbers as a fraction in the form p over q, where p and q are integers and your q should not be equals to 0. Then they've said we should simplify our answer in its lowest terms. Okay, let's start with A. We've got 4.3 repeating. Okay, in this case, what am I going to do? I can choose any letter. I can say I'm going to get x. So let x is equals to the same expression. Okay, now the next step that I'm going to do is that I'm going to multiply by 10 on both sides. Let's say this is my left hand side, this is my right hand side. Okay, I'm going to multiply by 10. On my left hand side, when I multiply by 10, I'm going to have 10x. On my right hand side, when I multiply by 10, the point is just going to move one step. Therefore, I'm going to have 43.3 repeating. Okay, now what I'm going to do is that I'm going to name this one as equation number 1, this one as equation number 2. Then I'm going to subtract equation number 2 minus equation number 1. So in this case, we have 10x minus x is equals to 43.3 repeating minus 4.3 repeating. Okay, on my left hand side, 10x minus x, that will give us 9x. This will be equals to 43 minus 4, that is a 39. Okay, then I divide by 9 on both sides. X therefore be equals to, I'm going to look for a number that can simplify this expression. 3 can achieve that. So 3 into 3, that is a 1. 3 into 9, that is a 3. Then again 3 into the 9 down, that will give us a 3. So basically this is a simplified form. We've expressed it in the form of p over q, which is a fraction. Now the way you confirm this, because you're not allowed to use a calculator, you can just punch this on the calculator. It is still going to give you the same answer there. Okay, so basically that. Okay, we come to B. Okay, so we're going to let any letter, let x is equals to negative 0.255 repeating. Okay, so look at where the point is. The point is here. Our target is to make sure that the point is very close to the numbers that are repeating. So in this case, the point is supposed to move one step there. Okay, ideally. Now in this case, I'm going to multiply by 10 for it to move, you know, that to move one step forward. So I'm going to multiply by 10 on both sides. So it means on my left hand side, I'm going to have 10x is equals to negative 0.255 repeating. Okay, now that the point is very close to the numbers that are repeating, I'm now going to multiply by based on the decimal places that we have for the numbers that are repeating. Since there are 2 of them, I'm going to multiply by 100 on both sides. This side I'm going to have 1000x will be equals to negative 0.255 repeating. Okay, basically that. So we've got 3 equations, the one that we started with, then the last 2. So always get the last 2. We're going to ignore the first one. So this one will be equation number 1. This one will be equation number 2. Then we're going to subtract equation number 2 minus equation number 1. So in this case, our equation number 2 is 1000x minus 10x. That will give me 990x. This will be equals to, now I'm subtracting. Every time there's a repeating and I'm subtracting, those areas will give me zeros. Therefore, I'm just going to subtract Here there is negative 0 to, now the 0 in front doesn't really change anything, so in this case I can write it as negative 255 minus, now don't forget this one also has a minus, so we have a minus 0 2. Okay, now the minus and the minus, they are following each other, so they'll just give us a positive there, so plus 0 2. Okay, so 990x will be equals to negative 255 plus a 2, that will just give us negative 253. Therefore now x will just be equals to negative 253 divided by 990. Then if there's no number that can go into both of these numbers, then that is our final answer. It has been expressed in the form of P over Q, where our Q is not equals to 0. Okay, basically those are rational numbers. Okay, let's solve C as well. We've got we're going to let, we can choose any letter. Let x is equals to 12.3411 repeating. Okay, so likewise we're going to multiply by, in this case the point is here, want it to be close to the numbers that are repeating, so the point in this case to move 2 steps, 1 2. Okay, so for it to do that, we're supposed to multiply by 100 on both sides. So on my left hand side I'm going to have 100x. On my right hand side I'm going to have 4.11 repeating. Okay, now that the point is very close to the numbers that are repeating, I'm now going to multiply according to the decimal places of the numbers that are repeating. We have two numbers in this case. I'm going to multiply by 100 again on both sides. So this, on my left hand side I'm going to have 10,000 x. This will be equals to, on my right hand side I'm going to have 123,411.11 repeating. Okay, so like we did with the previous one, we're going to name this one as equation number 1, this one as equation number 2. Then you're supposed to subtract the two equations. So in this case we've got 10,000x minus 100x. So what is that one going to give me? It's going to give me 9,900 actually, x. This will be equals to, then the other one, 123,411 minus 1234. Okay, so for this one I'm getting 122,177. Then I'm going to divide by 9,900 on both sides to get our x. Okay, so these are going to cancel, so our x therefore will just be equals to this same number, 122,177 over 9,900. So basically this is how we prove, you know, in terms of fractions, proving that the repeating decimal is a fraction. Let's solve question number 2. Assuming that root 2 and root 3 are irrational numbers, then we're told to prove that each of the following is an irrational number. Okay, so these are the questions that we have. Now basically, what are we supposed to understand? An irrational number plus an irrational number will always give you an irrational number. Okay, an irrational number plus an irrational number will give us an irrational number. Okay, then even if we have a rational number and we're subtracting an irrational number, we're still going to get an irrational number. That is also very important for us to understand. Okay, then a rational number plus a rational number will always give us a rational number. Okay, so basically these are some of the basics. Now examples of irrational numbers. The common ones are the square root of prime numbers. Prime numbers, we've got 2, 3, we've got 5, we've got 7, we've got 11. Numbers that only have two factors, only one and itself. Those are prime numbers. So in this case, if we square root these numbers, it's going to give us these numbers we call irrational numbers. They cannot be expressed in the form. The questions were just from solving rational numbers. They cannot be expressed in the form of P over Q, where P and Q, these ones are integers or members of integers, and our Q should not be equals to 0. So they cannot be expressed in that form. Then the other thing is that they've got a non-terminating decimal, of course. Let's say we can have 0.2345, maybe 1, 7. Now these numbers are going to be going, but there will be no pattern that is going to be, realized. So ideally, those are irrational numbers. Now that we've talked about that, let's now just analyze these ones. So this 3 is a rational number. Root 2 on top is an irrational number. We said when you're adding irrational number and irrational number, you're going to get an irrational number. So this is an irrational number, this is a rational number. It is the same. So we're going to get an irrational number. Here we've got an irrational number plus a rational number. We're still going to get an irrational number. So basically all of them, they're going to give us irrational numbers. Now how do we now then prove? So we can prove by contradiction. Okay, so let's start with our A. Our A, we are saying 3 plus root 2 or x. So I can let maybe even any letter in this case. If I'm going to say I choose maybe x, okay, I let x to be this same expression, 3 plus root 2 over 2. Okay, now what we should understand is that if we were to suppose that this x is an irrational number, or it's a rational number actually, because we know that when we add a rational number and an irrational number, we're going to get an irrational number. But now we're just supposing that instead of us having an irrational number here, we suppose that this x is rational. Okay, so we're going to suppose, we're not saying it's a rational number, we are supposing. So suppose x is rational. Okay, now if really x is a rational number, what this means is that if we're going to say, if we solve this one as an expression, we're literally going to have our x as an answer. Now this x, let's call it r. Okay, r in this case, because we're saying it's a rational number, it can be any real number that we can have after we solve that equation. This would be 3 plus root 2 over 2. Okay, what I'm now going to do is that I'm going to multiply throughout by 2. I'm going to have 2r will be equals to that is 3 plus 2 root 2. Okay, now that I've got this, what do we now do? Okay, actually this is 6. Okay, so this will be 6 when we multiply by 2 throughout. Okay, here it will be 6. Okay, basically that is what we have. Now if we're maybe to make it interesting a bit, if I divide, let's say, by 2 throughout again, I'm going to have 2 there and 2 there. Okay, it's going to take us back. But now what this means is that if I'm going to make which one can I make as a subject to the formula? Okay, I wanted to make 2 root 2 the subject to the formula. So in this case, we're able to see that this expression since root 2 itself is an irrational number, then if we're looking at 6, this one is a rational number. What this is going to give us this answer, which is rational number, which just is a contradiction. A rational number plus an irrational number cannot give you a rational number again. So therefore, in this case, our x is irrational. Okay, basically that. Let's solve b. For b, we are saying the square root of 2 minus 1. Okay, now again we're going to suppose that this expression, the square root of 2 minus 1, will be equals to, it's going to give us a certain answer, right? A certain answer. That answer we're going to call it a real number, so I'm going to put just r there. Okay, now real numbers in this case, they are members of, in this case, let's say this answer we're getting is a rational number. Okay, we are supposing, otherwise you cannot get a rational number. If you add an irrational number plus a rational number, you cannot get a rational number, but we're just supposing. Okay, so that is why we're putting like that. So in case maybe you didn't understand the second one, the first one, you can also understand this one. So in this case, I'm going to take the 1 on the other side. I'm going to say root 2 will be equals to, when the negative 1 goes on the other side, I'm just going to have r minus r plus 1 actually. Okay, now this is really a contradiction. So we're saying r, which is a rational number, plus 1, which is a rational number, is going to give us root 2, which is an irrational number. So now you know that an irrational number plus a rational number, let me use the symbol for irrational number. A rational number plus a rational number cannot be equals to an irrational number. Okay, so therefore this proves that this is really a very big contradiction. Okay, therefore in this case this is irrational as well. Okay, by contradiction. Then for the third one, c, is not very different. We have c, we've got 2 plus root 3 over 5. Okay, so now when we solve this whole expression, it's going to give us a certain, real number. In this case, let's call it r. Now you know that this r is a member of rational numbers. We are supposing that that's what it's going to give us. Okay, so this is a suppose. Okay, so we suppose that it's that. Now when I cross multiply, I'm going to have 2 plus root 3 is equals to the 5 multiplied by r. I'm going to have 5r is a member of rational numbers. Now to make it interesting, I'm going to make root 3 the subject of the formula. So root 3 will be equals to 5r being a member of rational numbers. When the 2 goes on the other side, it becomes a minus 2. Okay, now let's analyze this 5 is a rational number. A real number is it being a member of rational numbers. It's also a rational number. We've got 2 there. It's a rational number. Now a rational number plus another rational number cannot give us an irrational number. So this contradicts our supposition. Okay, so it contradiction in here. So this one is also irrational. Okay, so basically that is what we're talking about. Always try to make sure that the one with the root, or you're trying by all means to make sure that the one with the one that is irrational, you equate it to those ones which are rational. Therefore it's going to contradict the whole statement. So basically these are irrational numbers. So for you to understand more about rational numbers, you can also watch some of our videos that we did on the same. So let's come to question number 3. Without using a calculator, simplify each of the following. So A, we've got 2 root 27 minus 3. Okay, let me just solve it the way it is. I'm just going to put 2. Now for 27, we're going to look for two numbers that we can multiply, to give us 27. Now here we have to be very careful. We are always choosing perfect squares. Perfect squares are, if I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When I square all these numbers, the answers that I'm going to get are what we're calling perfect squares. So those are our targets. 1 squared is a 1, 2 squared is a 4. Here we have a 9, we have a 16, we have a 25, 36, 49, 64, 81, 100. Okay, you can keep on going. So we're targeting these numbers because the square root of these numbers is going to take us back to these numbers. So these answers that we've just written down, the ones I'm rubbing, they are called perfect squares of those numbers. So now let's start with the first one. We're saying 2. So for 27, which two numbers can we multiply? 9 multiplied by 3, right? Minus 3. For 48, which two numbers can we multiply? In this case, I always start from the if we've got 48, no matter how big the number is, try to divide by 2 first. Okay, so in this case I'm going to have 2 multiplied by 2 into 4, that is 2 into 8, that is 4. Now 24 is not a perfect square, so I'm going to try another one. Let's try 3 into 4, that is a 1. Okay, that is a 1, remainder 1. 3 into 18, that is a 6. It's a 6. Okay, multiplied by 3. Actually, I just have to write the way I wrote the other one. 3 multiplied by 16. Now 16 is a perfect square, so always go for such numbers. So in this case, I'm going to put 3 multiplied by 16 there. Okay, so for 75, not very different. It's the same concept. If I have the square root of 75, okay, and if I'm very stuck, what do? I'm going to start with the same process that I've just showed you. Let's say this time around I use 2. Okay, now if I use 2, I divide 2 into 7, that is 2 into 7, that is 3, remainder 1. 2 into 15, you're able to see that 2 into 15 is going to give us a decimal. We don't want decimals, so therefore I'm going to try another number 3. So 3 into 7, that is 2. So that is a 2. Then remainder 1. 3 into 15, that is a 5. Okay, now 5 is a perfect square, so we're going to go for 3 and 25. Okay, so basically this is how you do for all of them. So plus we're going to have root 25 multiplied by 3. Now you can just separate these ones. We're going to have 2, the square root of 9 multiplied by the square root of 3 minus 3, the square root of 3 multiplied by the square root of 16 plus the square root of 25 multiplied by the square root of 3. Then you just solve. Here we're going to have 2, the square root of 9, that is a 3. Root 3 there, minus 3, root 3. Then the square root of 16 there, it is a 4. Okay, now here we have to be very careful. Let me just write it different. I'm going to put a 4 in front, then I put root 3 there, then plus the square root of 25, it is a 5, then there's root 3 there. Now what I'm going to do, I'm now going to multiply these front numbers, this one and this one, this one and the other one. So in this case, 2 multiplied by 3, that is a 6, so I'm going to have 6 root 3 minus 3 multiplied by 4, that is going to give us a 12. Then we're going to have root 3 plus 5 root 3. Now able to see that now we have like terms, root 3, root 3, root 3, and in front we only have numbers. This is the same as if I put 2x, let's say plus maybe 5x, maybe plus x. It's the same, we only have coefficients in front and all of them are x. So don't be confused when you see something like this. So in this case we're going to have 6 minus 12, it will give us negative 6. Negative 6 plus 5, we're going to have a negative 1. Then we have a root 3, okay, like that. But for it to look nice, I'm just going to say negative root 3, okay. So basically that is the answer for A. Let's go to B. So for B, we've got root 80 minus root 20 minus 2 root 45. Okay, so we start with 80. Okay, so 80 in this case, what are we going to get? Let's say our root 80 is here. Let's start with 2. If I divide by 2, I'm going to get 2 multiplied by 40. 40 is not a perfect square. Let's go to 3. If I divide 3 into there, 3 into 8, that is like 2 remainder 2. 3 into 20, it will give us 6 remainder 2. So we don't want those remainders, so we're going to go for another one. Let's try 4. 4 into 8, we are going to have 4 multiplied by 4 into 80, that is 20. 20 is not a perfect square, so this one doesn't qualify. Let's try 5. 5 into 80, that is 1, remainder 3. 5 into 30, that is 16. 16 is a perfect square. Okay, so we're going to go for this one. So that's what we're going to put here. 16, the square root of 16 multiplied by 5 minus, for 20, what are we going to write? So 20 can be simplified as 4 multiplied by 5, right? Okay, minus 2. For 45, the common one is 9. 9 multiplied by 5. Then we just solve. The square root of 16, that is a 4. Then that will be root 5. Minus the square root of a 4, it will be 2. Okay, then root 5. Minus the square root of a 9, that will be 3. Now that 3 is going to multiply with the 2 there, we're going to have a 6. Root 5. Okay, since we have the like terms, we're just going to say 4 minus 2, that is a 2. A 2 minus 6, we're going to have a negative 4. So we're going to have negative 4 root 5. So this will be our final answer. So now the last question here, we have C. C is equals to root 28 over root 175. Okay, so basically that you can also try these expressions. Now which two numbers can give us 28? So in this case I think 4 and 7 can do that. So I'm going to have square root of 4 multiplied by 7 over, let me just put a multiplication there to avoid confusion. Then for 175, it is going to be the square root of 25 multiplied by 7. Okay, so basically that. Now what are we going to have? The square root of 4, that will be 2. So I'm going to have 2 root 7. Then I'm going to have the square root of 25, that is a 5 root 7. Then now what am I going to do? The root 7 and root 7 can cancel. In this case I'm just going to have 2 over 5. As simple as that. We come to question number 4. We're told to rationalize the denominator of each of the following. Okay, so you don't want a rational number, or you don't want a surd in your, as a denominator. That's rationalization. So every time you're rationalizing, especially the denominator, you multiply the numerator and the denominator by the conjugate. Okay, so like for A, let's start with A. We've got the square root of 2 minus 1 over 1 plus root 2. So in this case we're going to multiply by the conjugate, which is 1 minus root 2 on both sides. 1 minus root 2. Then we just need to solve. Okay, so I'm literally multiplying this and that. Okay, so like just the normal expansion, if I start multiplying root 2 multiplied by 1, I'm just going to have root 2. Okay, then the same root 2 multiplied by, negative root 2 there, I'm going to have negative 2. Why? Because root 2 multiplied by root 2 will give us 2 according to the rule of SURDS. So that's what we're going to have. Then I start with a negative 1. Negative 1 multiplied by 1 there, I'm going to have negative 1. Then when the negative 1 multiplies with the negative root 2, I'm just going to have a positive root 2. Then when I come down, you're able to see that because I'm multiplying these ones as well, this is a difference of two squares. Okay, difference of two squares. If I've got a minus b, then I've got a square there. What this means is that it is a minus b, then again it is a plus b. So that is what we have there, plus and minus. So because we've got that, you can, if you want, you can solve everything one by one. You multiply, or you can just get the one with a negative and you square like that. You're still going to get the same answer. But for this first example, let's solve it just the normal way. In this case, I'm going to multiply 1 by this whole expression, so it means that one is going to be maintained. I'm going to have 1 minus root 2. Then when the root 2 multiplies with the whole expression, I'm going to have plus root 2 minus 2. Okay, then now we solve. On top, I've got what do I have? I've got root 2 plus root 2. I'm going to have 2 root 2. Then I've got negative 2 minus 1. That will give me a negative 3. Okay, now I come down here. I've got a negative root 2 and I've got a positive root 2. That will give me 0 in the middle. So I'm just going to remain with 1 minus 2. Then I just need to solve this expression. So I'm going to have on top, I've got 2 root 2 minus 3 over 1 minus 2. That is a negative 1. Okay, so now if I solve the whole expression, in this case now it's going to be negative 2 root 2 plus 3. Okay, so if you want, you can also write it as 3 minus 2 root 2. Okay, so basically that is going to be our final answer. But I just want to explain something. The denominator gave us a negative 1. So the other expression I was saying, always go for because it's a difference of two squares, get the one with a negative, which is 1 minus root 2. Then you do squares. Okay, now because we've done, this is a difference of two squares, so what I'm just going to do is it's going to be 1 squared minus, I get the root 2 squared, like that. So so that you don't waste a lot of time, 1 squared, that is a 1. Okay, minus root 2, then there's a square, so the square and the root will cancel. So in this case, I'm going to have a 2. 1 minus 2 to give us a negative 1. That's how we're able to have a negative 1 there. And this is the method we're going to use throughout the all these other questions, because it's faster. So now we're going to go for B. We've got root 3 minus 2 over root 3 minus 1. So we're going to multiply by the conjugate, which is root 3 plus 1 root 3 plus 1. Okay, when I come to the numerator, what do I have? I'm just going to have root 3 multiplied by root 3. That will just give us 3. Okay, then I'm going to have plus root 3. Then I come to negative 2 multiplied by root 3. I'm going to have negative 2 root 3. Then negative 2 multiplied by 1, I'm going to have negative 2. Then down, I'm just going to get the one with a negative, and I'm going to square each of them. So I'm going to have root 3. I square this one. I put my minus, and I put my 1, and I square it. So basically, that, we're still going to get the same answer. So now on top, if I solve, I've got what do I have in common? Okay, so I've got a 3 and a negative 2. 3 minus 2, that will give us a 1. Then I've got root 3 and 2 root 3. Those are common, or they're like terms, so it's going to be root 3 minus 2 root 3. What is that going to give us? It's just going to give us minus root 3, okay, over, now the square and the root are going to cancel. I'm going to have 3 minus 1 squared is a 1, so 3 minus 1, that is just a 2. Okay, so I'm going to write it in advance there. So that is the answer that we have. Then yeah, so this is our final answer. We can't simplify it further, it's already simplified. Okay, so that is how we solve this one. Let's solve C. So for C, okay, so for C, we have 2 plus root 2 over the square root of 2 minus 1, then there's a square there. Okay, so you just have to make sure that you first solve what you have in your denominator as your denominator. So we're going to solve what root 2 minus 1 squared is there. So now if we're going to solve, this is to just solve it, in a faster way, get the first term, square it, then, so in this case I'm going to have, if I square that, what am I going to have? I'm going to have the square root of 2, then if I square it like that, the square and the root are going to cancel. I'm just going to remain with 2. Okay, so I'm going to put 2 there. Then I'm going to multiply this 2 multiplied by root 2, which is 2 root 2, multiplied by the negative 1. I'm going to have negative 2 root 2. Then I'm going to square the last one. Okay, I'm going to square the last one. If I square the negative 1, what am I going to have? I'm just going to have positive 1. So that is the easiest way to solve quadratics. Okay, so in this case, what am I now going to have? I've got a 2 plus a 1, that will give us a 3. Okay, minus 2, then root 2. So that is what we have as a denominator. So allow me to rub this part because we simplified it, which is 3 minus 2 root 2. Now we can solve the normal way. We're now going to multiply by the conjugate, which will be 3 plus 2 root 2. That is also on the numerator, 3 2 root 2. Then now we just simplify this expression. So for the denominator, I said you just get this, you square it, you also get that one, you square it. Okay, so now if I square 3, what am I going to have? I'm just going to have a 9, right? Minus, now if I square 2, this is 2 root 2. If I square this, okay, so I'm going to have 2 squared, that is 4. Then the square and the root are going to cancel for the second one. I'm just going to have a 2. 4 multiplied by 2, that is an 8. Okay, so we're going to have an 8 here. 9 minus 8, that will just give us a 1. Okay, then in this case, since a 1, when it divides with whatever we're going to have on top, we're just going to have that. So in this case, our answer therefore is just going to be, we just have to now distribute, or let me say expand what we have on top. So this multiplied by that. So 2 multiplied by 3, that is a 6, plus 2 multiplied by 2 root 2, I'm going to have 4 root 2. Then root 2 multiplied by 3, I'm going to have 3 root 2. Then root 2 multiplied by 2 root 2, what am I going to have? So root 2 multiplied by 2 root 2. So you have to be very careful, plus, because I'm multiplying root 2 multiplied by 2 root 2. So my final answer is going to be, the 2 is going to be maintained, but now the root 2 multiplied by the root 2 will give me a 2. Okay, then a 2 multiplied by 2 will give us a 4. So that is very, very important. So that is going to give us a 4 there. Then we just solve this expression. We've got 6 and a 4. We can add those ones. We're going to have 10 plus. Okay, we've got 4 root 2 and 3 root 2. So that will give us 7 root 2. So that will be our final answer. So basically that. Let's solve D. Okay, so D is also one of the simplest. So let's first solve what we have on top, because it's not simplified fully. So we've got on top, we've got 3 root 27 minus 48. Okay, so we're going to have 3. Then for 27, we said two numbers that you can multiply. So there's a 3 and a 9. Okay, now the square root of a 9, it will be a 3. Okay, then we're going to have root 3 there. Minus, for 48, two numbers that you can multiply. Okay, 16 multiplied by 3. Okay, now that will give us the square root of 16, that is a 4. Then root 3. Then you just solve this expression. 3 multiplied by 3, that is a 9 root 3. Minus 4 root 3. Now 9 root 3 minus 4 root 3, that will just give us 5 square root of 3. Okay, so basically that is what we have on top. Okay, okay, so we are saying we have 5 root 3 on top, divided by root 3 minus root 2. So we're going to multiply by the conjugate on both sides, the denominator and the numerator. So that will be root 3 plus, again also root 3 plus root 2. Okay, for the denominator, we're going to do like we've been doing, but let's first solve the numerator. In this case, we've got 5 root 3 is multiplying by the whole expression. So when it multiplies with 5 root 3, when it multiplies with the 3, with the root 3, we're going to have root 3, and root 3 will give us a 3. That 3 is going to multiply with the 5 in front. We're going to have a 15 there. Okay, then plus the same 5 root 3 multiplied by root 2 there. So we're going to have 5, but since we've got root 3 and root 2, so this is going to simplify as 3 multiplied by 2 in the brackets. So our final answer will be 15 plus 5. In the brackets, we are going to have 6. Okay, so this is how we solve this one. Determine the greater of each pair. Determine the greater of each pair. So which one is greater? Let's start with A. So we've got the absolute function of 4 plus negative 2. Let's solve this expression first. So every time you're talking about, modulus or the absolute value, it always gives you a positive answer. So I can have a negative 8. This will still give us an 8. I can have a 7. This will give us a 7. You are always going to be getting positive answers. Those are absolute functions. So in this case, what do? We're just going to find, since there's a positive and a minus there, I'm going to have 4 minus 2. Okay, then there's the absolute, you put the absolute bars. Then 4 minus 2, that is a 2. Now the absolute value of 2, that is just a 2. This is the first one. Then the second one is this one. We've got negative 4 plus negative 2. Okay, so what do? Find the absolute value of negative 4, which will just give us 4. Then there's a plus in the middle. Then find the absolute value of negative 2, that is a 2. Okay, 4 plus 2, that is a 6. That will give us a 6 as the final answer. So now the question is determine the greater of each pair. So we're able to see that 2 itself, if you're going to look at 2, 2 is less than 6. Therefore, our greater pair will be, I'm just going to write GP. Our greater pair is that one, -4 plus -2, like that. The second one, this will be our greater pair. So that is how we solve the first one. We come to the second one, it's the same thing, not very different. So for the second one, we can just even solve it from here. This one, we solved it, it's the same as the first one. They're not very different. It gave us 2. Okay. Then when we come to the other one, maybe we can solve the other one. This we've got 4 there plus -2. Okay. So we're going to have 4 there. Then, okay, the absolute value of 4, that is just a 4. Then plus the absolute value of a -2, that is a 2 still. Therefore, we're going to have the absolute value of a 6, which will give us a 6. So in this case, we're able to see that this pair is also greater in the second one. Let's solve C. We've got the absolute value of, this is -2. So let's start with this first one. So we're going to have 1. Now we've got a negative, and the negative there, they'll give us a positive. So we're going to have 4 plus 2. That will just give us a 6. Okay. Then we come to the other one. The other one, it is absolute value of 4 minus, we've got a 1 there, we've got a -2, like that. Then you just have to solve this one. The absolute value of a 4, that is a 4. Okay, then there's that will give us a plus, not a plus actually. So here we have to be very careful. So this is an absolute bar actually. So we're supposed to solve this part. We're going to have minus, but when we solve that absolute bar, it's going to give us a 2. Okay. So this is where we're supposed to be very, very careful. It's a bit different from the other one. This one, here we have the plus, here we have a minus. Okay. So you solve first what you have as absolute. You solve this one, it gives us a positive. It gives us a positive. But don't forget there is this negative. That's why I have to put a negative there. Now a 14 minus a 4 minus a 2, that will just be a 2. The absolute value of 2 is just a 2. So which one will be the greater pair? So the greater pair is the one that gave us 6, which is the first one there. So that is how we solve these ones. Then let's solve 6. Evaluate each of the following powers. Okay, so these are complex numbers. Okay, now what you should understand is that the square root of a negative number is a complex number. Okay, so if I've got the square root of -1, now the square root of, if I say the square root of -2, that is still a complex number. As long as it's a negative there, it will be a complex number. Now the square root of -1 is equals to I. Okay, when it comes to complex numbers. So if we have, let's say, the square root of -2, so this will be equals to this will be, you can even separate it, the square root of 2 multiplied by I. Okay, which will be just the square root of 2I. Okay, so basically those are the expressions that you need to understand. Then some basics is, if I is to the power 1, it will just give us I. Okay, however, if we say I to the power 2, what is it going to give us? It's going to give us a -1. Why? Because we are saying I itself is the square root of -1, and if we are to square this, the square and the root are going to cancel, just going to have -1. That's why we're finding 1 there. What if we put another number? Let's say now it's I to the power 3. I to the power 3. What are we going to have? So I to the power 3 is just going to give us -I. Okay, why? Because this is I multiplied by I multiplied by I. Okay, multiplied by I. Now we've said I multiplied by I, which is I squared. I squared gives us a -1. So we're going to have -1 multiplied by I. Now, -I multiplied by -1 multiplied by I, that will just give us -I. That's why I'm saying I to the power 3 is equals to -I. So that is very important. Then let's say if we say the last one, if we say I to the power 4. I to the power 4 is just equals to a 1. Okay, so it's equals to a 1. So how is it equals to a 1? If we say I multiplied by I multiplied by I, we said the first two I, they're going to give you a -1. Okay, multiplied by, even these other ones, they're also going to give you a -1. A -1 multiplied by a -1, that will just give us a +1. So these are some of the basics that you're supposed to understand to solve this question effectively. Okay, let's start with the first one. We've got I to the power 3. So we've already talked about what I to the power 3 is. It's going to give us -I. Then we come to B. B, we're finding I to the power 6. I to the power 6. Okay, so I to the power 6, we can break it down. We can break the 6 down. I'm going to have I to the power 4. Okay, then I can even put a 2 outside, or I say I to the power 2 there. Okay, because we know that those ones are going to give us a 6 there. So now, if we solve this, what is it going to give us? I to the power 4, we've said it is 1. I to the power 2, we've said it is -1. -1 multiplied by 1, that will just give us a -1. So I to the power 6 gives us a -1. Okay, we come to D, actually C. C, we've got I to the power 15. Now, I to the power 15, we can also just break it down. It can be I to the power 12 multiplied by I to the power 3, because those ones, every time you're multiplying and you have the same base, you're going to add the powers. 12 plus 3 will give us 15 still. Okay, so now what do we do? I to the power 12, in this case, because 12 itself, it's an even number. Okay, so we're able to see that 12 to the power I to the power 12, that will just give us a 1. Okay, just the way I to the power 4 gave us a 1, because even numbers are going to give you a 1, but mostly you have to be very careful with the odd numbers or the other type of numbers, prime numbers. So here I to the power 3, we said it is -I. Okay, this one. So now we're just multiplying, so this means the final answer will be -I. Okay, so that is our C. Our D, so for D we have I to the power 40. So I to the power 40, again we're just going to have I to the power 4. This is multiplying by 10. Okay, so in this case I to the power 4, we're saying it is a 1. Okay, because 4 is an even number. Then we're going to have to the power 10, and 1 to the power 10, that will just be a 1. So I to the power 40 is a 1. Okay, then we've got the last one, D. We've got I to the power 90. I to the power 90. Okay, so for this one, again, we're going to target at least a number where 2 can go into, at least very, very close numbers. So I'm going to have I to the power, let's say 88, multiplied by I to the power 2. Okay, so in this case, what do? I'm going to have I can again separate the 88 to something maybe simpler. I'm going to have I to the power 4 multiplying by, let's say 22. This is multiplied by I squared, we said it is a negative 1. Okay, now that we've got that, I to the power of 4, that is a 1, because we said it's an even number, so to be a 1 to the power 22 multiplied by negative 1. Now I 1 to the power 22, that will just be 1 multiplied by negative 1. So this way expression 1 multiplied by negative 1 will give us a negative 1. So this is how you solve, you know, these types of numbers, especially as far as complex numbers are concerned. Let's solve question number 7. We're taught to simplify each of the following, giving our answers in the form a plus ib, where a and b are members of, or they are real numbers. Okay, so we've got this. Okay, so these are complex numbers, so we have to first distribute the negative here. Okay, so we're going to have 2 minus 3i minus 1 plus 2i. For a complex number, it always has a real part and an image part. This is a real part, this is the image part. Okay, so basically those are the basics. So now, us understanding that, we're just going to add the real part alone and the image part alone. You can't do the opposite. So in this case, this is a real part and this is a real part. We're going to add them alone. This is an image part and this is an image part. We're also going to add them alone. So I'm going to have 2 minus 1 alone. Then there's a plus. I'm going to have negative 3i plus, okay, plus, okay, not really plus, actually we've made a mistake somewhere here. So this is not supposed to be like this. We're saying when we're distributing the negative, that would that was supposed to be negative 1 there, then minus 2i. Okay, I thought like I'd done it at first. So now what do we now do? We're going to have we've already gotten the 2 and the negative 1. Now we're going to get the negative 3 and the negative 2. Okay, so I'm going to have negative 2i. Let me just start with negative 3. Negative 3i minus 2i. Okay, basically this. Then when I add the real parts, so 2 minus 1, that is a 1. Then a negative 3i and then negative 2i, that will give us negative 5i. So that is how we solve the first one. Not very complicated. Then we come to b. Okay, so for b, we've got 3 minus I, then there's a square outside. So we just solve just the way we solve if we're expanding. So 3 squared, that would be a 9. 2 multiplied by 3, that is a 9. A 9 multiplied by I, that is 2 multiplied by 3, that is a 6. A 6 multiplied by I, I'm going to have negative 6i. Then the I will be squared. I'm going to have plus, in this case, I'm going to have negative I squared. That will give us positive I squared. Then, what do I now do? I'm going to have 9 minus 6i. Now, I squared, that is just a negative 1. Like we've been saying, when we're solving complex numbers, even these are the complex numbers, but where i's are concerned, because I is the square root of negative 1. So if you square that negative 1, it's just going to give you, if you square root this, if you put a square on the square root of negative 1, you're just going to get a negative 1. Now that we've got this, 9 minus 6i, so we can, this is a real part and this is a real part, so 9 minus 1, that will give us 8. So we're going to have 8 minus 6i. So that is our final answer for B. So for C, okay, so C and D, I think they're the same. So we're going to have C first, 1 plus 2i. This is squared over 2 plus I. Now here, what are we supposed to do? Let's first solve what we have on on top. So we're going to have expand. We're going to expand that one. We're going to have 1 squared plus 2 multiplied by 1, that is a 2. 2 multiplied by 4i, we're going 2 multiplied by 2i, we're going to have 4i. Then the 2i squared, 2 squared, it's a 4. Then we're going to have I squared. Okay. Then down we got 2 plus I. Then we can solve what, so this is 2 plus I. Now we can solve what we have on top. We've got 1 plus 4i. Then we've got I squared. I squared is a negative 1. Then we've got a 4 there, so it's going to be negative 4. So now when we solve what we have on top, 1 minus 4, that will give us a negative 3. So I'm going to have negative 3 plus 4i over 2 plus I. Okay, now that we've got this, I'm going to now multiply by the conjugate of the denominator. So I'm going to have 2 minus I, 2 minus I. Then I solve. Okay, so what are we now going to do? I'm going to, the way we've been doing SURDS, I'm going to just get the one with the negative and square it. So in this case, I'm going to have, when I square 2, I'm going to have 4, okay? Minus, when I square the I, I'm going to have negative 1, okay, as a denominator. You remember, or you can just do it the way we always do it. You just distribute 2 multiplies with everything, I multiplies with everything. It's still going to give you the same answer like we've done, because this is a difference of 2 squares. So I just have to get this one, I square it, and the I square it, then I solve. Okay, so that's what we've done. So our job now is just to solve what we have on top. So we've got now here we are supposed to distribute normally. Okay, expand the way we expand. So negative 3 multiplied by 2, that will give me a negative 6. Negative 3 multiplied by I, I'm going to have positive 3i. 4i multiplied by 2, I'm going to have 8i. Then 4i multiplied by negative I, I'm going to have negative 4i squared. Okay, so this is where we're supposed to be careful. Now this is 4, there's a plus and there's a minus and a minus. Those ones will give us a plus. So 4 plus 1, that is a 5. Now when I solve what I have on top, what does it equate to? I'm going to have negative 6, then plus 3i plus 8i, that will give us 11i. Okay, then we've got a negative here, then we've got I squared. I squared gives us a negative 1. Negative 1 multiplied by that negative, we're going to have a positive. Then we have a 4 there. Okay, so that is what we have. Allow me to rub this part. Okay, now what do we have? We have negative 6 plus 4. What does it give us? A negative 2 plus 11i over 5. Now the way we now completely simplify and write complex numbers is that you're going to write negative 2 over 5. This is the real part plus 11 over 5i. Okay, so you have we always have the real part and the imaginary part, or the image part. So basically this is our answer there. So let's solve D. So for D, we have 3 minus 2i, 2 minus 3i. Okay, let's first solve the one, the same one on top. We just expand it in advance, so that we're just going to replace by the denominator later on once we find the answer. So here, we're going to have 3 multiplying with everything that is in the bracket on the other side. A 3 multiplied by 2, that will give us a 6. A 3 multiplied by negative 3i, we're going to have negative 9i. Then negative 2i multiplied by 2, we're going to have negative 4i. The negative 2i multiplied by negative 3i. 2 multiplied by 3, that is the 6. But now because there are negatives there, I'm going to have positive 6i squared. That's where you have to be careful on. Then this is 6, negative 9i minus 4i, that will give us negative 13i. And then we've got I squared there, that is a negative 1, multiplied by 6, it's negative 6. Now 6 minus 6, that is a 0. So our final answer here is just negative 13i. So this whole expression on top gives us negative 13i. Okay, so I'm just going to rewrite it again. We're going to have negative 13i divided by everything that we have now, 1 plus 2i. Then when we have that, that's when now we solve by we multiply by the conjugate of the denominator. This is 1 minus 2i over 1 minus 2i. Then from there you just solve what we have down. I'm going to do the difference of two squares. This will be 1 squared. Okay, to be 1 squared minus 2i squared. Okay, on top, if I multiply 13i multiplied by 1, that will just be 13i. It's negative 13i. Negative 13i multiplied by negative 2. We are going to have positive 26i squared. Okay. Okay, now we can solve. We're going to have negative 13i. Now, I squared, that is a negative 1. So we're going to have negative 26 there. Over 1 squared is 1. Minus 2 squared is a 4. I squared is a negative 1. So here we're going to have a positive 1. Okay, a positive actually. Then when you simplify this, it is negative 13i minus 26 over 5. Okay, over 5. Then what do we now do? Okay, what do we now do? I can now just rearrange what we have. I'm going to have negative 26 and negative 13i over 5. Okay, now our final answer, you know that you have to have the real part and the image part. So we're going to have negative 26 over 5 minus 13 over 5i. Okay, so that is our final answer. So this is how we solve these questions on complex numbers. Okay, we come to question number 8. Given that z is equals to that, z2 is that, and z3 is that, find the answer to each of the following in the form a plus ib or bi, where a, b are real numbers. Okay, so let's start with the first one. We've got z and z2 and z divided by z3. So this is not very complicated. So we just replace what is z1, which is 8 plus 2i. Then z2, it is 2 plus I. Okay, divided by z3. z3, it is 3 plus I. Then we just need to solve this expression. So in this case, what do we have? We distribute what we have on top, or we expand actually. 8 multiplied by 2, that is a 16. 8 multiplied by I, that is 8i. Then 2i multiplied by 2, we're going to have 4i. Then 2i multiplied by I, we're going to have 2i squared. So don't forget your denominator, 3 plus I. Then we simplify on top. We're going to have 16 here. Here we've got negative 2i. Okay, negative 2i squared. Now I squared is negative 1. Okay, that negative 1 multiplied by 2, it will be negative 2. Now we've got 16. So 16 minus the 2 there. 16 minus the 2, we're going to have 14. Okay, plus, then we've got 8i plus 4i. That will give us 12i. Okay, then we've got 3 plus I, like that. Now if we simplify this, we're supposed to multiply by the conjugate on both sides, which is 3 minus I, also 3 minus I. Okay, basically that. So now when we solve what we have on top, what do we have? we're solving this, it's multiplying by that. You just have to expand. So 14 plus 12i, 14 plus 3, actually we're going to start with 14 plus 14 multiplied by 3, that would be a 42. Okay, then 14 multiplied by negative I, we're going to have negative 14i, then plus 12i multiplied by 3, that is 36i, then 12i multiplied by negative I, we're going to have negative 12i squared, over. Now this is a difference of two squares when you multiply them, so I'm just going to say 3 squared minus, then there's I squared. Okay, now we solve what we have on top. Now I squared, it is negative 1, then there's a negative here, so we're going to have positive 12 there. Positive 12 plus 52, we're going to have 54. Then when you add the ones that we have in the middle here, we've got negative 4i plus 36i, 4i plus, that would be 22i. Okay, so that would be a positive, actually positive 22i, over 3 squared, that is a 9, minus I squared, it's a negative 1. Okay, negative 1. Now negative 1 and there's a negative, there are two negatives there, they'll give us a positive, so it will be 9 plus 1, which will just give us a 10 there. Okay, so basically this is what we have as for now. What do we now do? We just now supposed to write it in the standard way. It will be 54 over 10 plus 22 over 10i. Okay, then when you simplify it further, your final answer now is now you can look for two numbers that can divide into both of them, or these numbers. So a 2 into 50, a 2 into 5, that is a 2, remainder 1, a 2 into 14, that is a 7, then a 2 into 10, that is a 5. Okay, then plus a 2 into 22, that is 11, a 2 into 10, that is a 5. So that would be our final answer. So that is how we solve the first one. So let's go to B. So B, we're solving those ones. We've got Z1 minus Z2. So I'm going to write what my Z1 is, which is 8 plus 2i. Then we've got minus Z2. Z2 is 2 plus I. Then I come divided by Z1, it is 8 plus 2i, plus Z3, it is 3 plus I. Okay, then from there I just solve. So okay, what do we now do from here? Just make sure that we've got 8 and 2 there, and there we have a minus there, so we're just supposed to solve them the way they are on top, because here we're not multiplying them, we're just subtracting them. So the real part alone and the imaginary part. So we've got 8 minus 2, that will give us a 6. Then 2i minus I, that will just give us an I. Okay, so we're going to have plus I, over, we come down as well, we're supposed to also do the same. 8 plus 3, that will give us 11. Then 2i plus I, that will give us plus 3i. Okay, so basically this is the one that we're supposed to do the conjugate. So we're going to have 11 minus 3i. Okay, and also on the numerator 11 minus 3i. Okay, then from here now you're just now supposed to solve. Now 11 squared, I'm going to do the, okay, let's just write it, 11 squared minus 3i squared, that is what we're going to have down. Then now when we distribute, when we expand on top, what are we going to have? 6 multiplied by 11, that is a 66. 6 multiplied by 3i, that is negative 18i. Then plus 11i. Then I multiplied by negative 3i, we're going to have negative 3i squared. So allow me to solve it this other side. So we've got negative 3i squared. I squared is negative 1. So that negative 1 multiplied by negative 3, we're going to have positive 3. So we're going to have 66 plus that 3. We're going to have 69. Then here we've got 11i and we've got negative 18i and 11i. So because the signs are different, we're going to subtract. We're going to have negative 7i over, now 11 squared is 121, then minus, okay, I forgot here it's also squared, so that would be 3 squared is 9, then I squared is a negative 1. Okay, that negative 1 is going to multiply with this negative to give us a positive there. So we're going to have 69 minus 7i over 121 plus 9, that will give us a 130. Okay, therefore our final answer now is going to be 69 over 130 minus 7 over 130i. Okay, so basically this is how you solve this one. So let's solve C. So for C, we've got Z1 minus 2Z3. Okay, so I'm just going to be replacing Z1 is 8 plus 2i. Then minus 2. Z3, it is 3 plus I. Then there's a square for everything. So I'm going to put it like this. The square will be outside. Okay, divided by 3 Z2. Z2 is 2 plus I. So this will be squared. Now I'm just supposed to now solve this expression. Okay, so here let's first distribute this part. So we're going to have 8 plus 2i, then minus 6 minus 6 minus 2i. Okay, so that is what we have. I'm not going to forget the negative outside. Okay, then on the other part, what are we going to do? So down there we have a square there. So what do we do? Okay, this one is also this, so this one is supposed to be like that as well. The square is outside. So I'm going to distribute again also the 3. The 3 multiplied by 2, I'm going to have 6 plus 3 multiplied by I, that is 3i. Then don't forget there's a square outside as well here. Then we solve what we have on top. So here, what do we now do? We've got 8 plus 2i minus 2. Okay, so here we've got 8 minus 6. That will give us a 2. Okay, and then we've got positive 2i and we've got a negative 2i. That will give us a 0. Okay, so basically we only have 2. Then there's a square outside, don't forget it. Then we come to the other one. The other one, it is 6 plus 3i. Now 6 squared, that is 36, plus 2 multiplied by 6, that is 36. 36 multiplied by what? 3i. Okay, so allow me to just write it on the other side. So 2 squared on top is going to be a 4 over, here we have 6 plus 3i, then there's a squared outside. Okay, so here we have to be very, very careful. So we're going to have 4 over 6 squared, that is a 36. Then plus 2 multiplied by 6, that is a 36. Okay, that is a 36. Then we've got I there plus 3. What do we have? 2 multiplied by 6, that is a 12 actually. Okay, and then a 12 plus that 3, what do we then have? Okay, I'm trying to solve this one nicely. What are we going to have here? So if we say, okay, let me just try to do something. This is 6 squared. Okay, it will be 6 to the power 6 squared, that is a 6. If I get the 3i squared as well, just on the other side, 3 squared, that is a 9. Okay, then I squared is a negative a squared is a negative 1, so we're going to have negative 9 the side. Then the one that we're supposed to put on the middle, that is where we are stuck. So we're going to say 2 multiplied by 6, that is a 12. Then a 12 plus 3i, we're going to have a 12 multiplied by the 3i, we're going to have 2 multiplied by 6, that is 36. No, that is 12. Okay, and then the 12 multiplied by the 3i, we're going to have 36i. Okay, so 36i. Yes, then we're going to have 4 there. Then we've got 36 minus 9. 36 minus 9, what does it give us? It gives us 27. Then we got a plus 36i. Okay, so now that we reached here, that's where now we do the conjugate. So we're going to multiply by the conjugate 27 minus 36i over 27 minus 36i. So allow me to rub the other side. Okay, now we're going to have the 4 multiplying with everything that we have on top. Here, that's where I use the calculator. 4 multiplied by 27, that is giving me 108 minus 4 multiplied by 36, I'm getting 144i over. Now I'm just going to get 27, I square it, minus, I'm going to get 36i, I also square that. 108 minus 144. Oh, actually I can't even do that because the other one is a real part, the other one is an imaginary part. So that one is just going to be the way it is. So I'm going to have 1080 minus 144i. Now 27 squared, 27 squared, what does it give me? So 27 squared, this is negative 36, no, negative 36, so 36 squared. So because we're going to just find, so I'm just going to do 27 squared plus 36 squared. Why? Because the I squared is a negative, then it's going to give us a positive there. So I'm just going to do 36 squared plus 27 squared. I'm getting 2025. Okay, so in this case we're just going to have 108 divided by 2025 minus 144 over 2025 I. Then if you want, you can now simplify this one further. Okay, so this was a very long question, but it's still, yeah, engaging, and it's not that very complicated. So if we're going to divide by 9 everywhere, 9 into 108, that will give us a 12. 9 into 2025 is going into 20, 25, we're going to have 225 minus 9 into 1, 44, that is a 16. 9 into 22, that is 2225. Okay, then there's I, don't forget your I, excuse. Then can we simplify it further? Of course. What are we going to divide by? 3 into 12, that is a 4. 3 into 2, 25. 3 into 21, that is 7, remainder 1, into 15, that is a 5, minus what's the number? Okay, 16 over 225 I. We're going to leave it there because there's no number that can go into 16 and the 225. So that is our final answer for this one. So question number 9, express z is equals to that in the form of p plus qi, where p, q, these ones are members of integers, of real numbers actually. So we want p plus so look at what we want, p plus qi in the form of this one, where p and q. Okay, so this p plus qi, want it to be equals to z. Z is equals to the square root of 4 plus 3i. Okay, if we're going to reverse, if we square root on both sides, we're going to have p plus qi, this is squared, this will be equals to, when square root on the other side, they're just going to cancel. So this side I'm just going to have 4 plus 3i. Okay, so if that is what we have, let me now solve this expression. So we're going to have p squared, 2 multiplied by p, that is 2p. 2p multiplied by qi, we're going to have plus 2pqi. Okay, then we're going to square root we're going to square root the qi. So we're going to have q squared and I squared. Now I squared is negative, so we're going to have q squared and I squared. So I'm saying I squared is a negative there. So a negative, so we're just going to have negative. We're going to have negative q squared is equals to 4 plus 3i. Okay. Now what we're now going to do is that we're going to equate the imaginary part and the ones with I. So the imaginary part, the real part, we've got p squared minus q squared, then plus 2pqi is equals to 4 plus 3i. So here you're able to see that these ones, they are the real parts. Okay, then the imaginary part is these ones with I, so we're going to equate them just the way they are. So in this case, what do we now do? So we're saying p squared minus q squared is equals to 4, then 2pqi is equals to 3i. Okay, now from here, what do we now do? So from the other expression, if we make okay, so the other expression is 2p. If I remove the i's, I'm just going to have 2pq is equals to 3, because the i's are going to cancel on both sides. Now from this expression, if I make one of them the subject of the formula, let's say I want to make q the subject of the formula, so that when we get that qe, we replace it there. Okay, so we're going to have q to be equals to 3 over, I'm going to divide by 2p on both sides. So that is what we have as q. So I'm going to replace that one into this equation. Okay, so we're going to have p squared minus q, we are saying it's 3 over 2p is equals to 4. Okay, hope we've written it correctly. Okay, but don't forget this is squared. Why? Because the q there is squared. Okay, now there, what do we now do? If we simplify it further, it's going to be p squared minus 3 squared, that is a 9, over 2 squared, that is a 4, then we're going to have p squared there is equals to 4. Okay, now what I'm going to do for us to remove this 4p squared, I'm going to multiply the whole expression by 4p squared. Okay, so what do we now have? Allow me to rub okay, what can we keep here? Okay, there, allow me to rub the top part. Okay, so when I multiply with 4p squared, I'm going to have 4p to the power 4. Okay, why? Because here is squared and the other one, the p is the other p is also squared. So we're going to have 4p squared minus q. Okay, minus q, because the other one, the 4p squared and the 4p squared are going to cancel, because that's what we want. We don't want fractions. Then we're going to have 4 multiplied by 4p squared. We're going to have 16p squared. Okay, now it's in the normal form. I'm going to have 4p to the power 4 minus, okay, 16p squared minus q is equals to 0. I've taken it the other side. Okay, now that we've got this, we can choose any letter to simplify our expression. I can let u to be equals to, let's say, p squared. So if u is equals to p squared, if I put it in this equation, I'm going to have 4u. Since this is squared, this is to the power 4. We're going to have 4u squared minus 16u, because p squared we're saying it is equals to u, minus q is equals to 0. Okay, now that we've got this, we can now solve this quadratic. Okay, we can now solve this quadratic. So which one can we? Okay, that one is still fine. We can remove that one. So as a quadratic, it's going to be u is equals to our b is negative 16, and this, quadratic starts with negative b, so it will be positive 16, positive or minus the square root of b squared, which is 16 squared. Now 16 squared, what does it give me? It gives me 256. Okay, plus 4ac, for our a is 4, c is 1. Okay, so 4 a c, we're saying our a, we've got 4, then a is what? Is 4. So a is equals to, we're saying b squared minus, let me just write it, b squared minus 4ac. Our a in this expression, it is a 4. Our c, it is a negative 1 there. Okay, so it is 4 multiplied by the 4 there, multiplied by the negative 1 there. Okay, so basically that, then divided by over 2a. Our a is a 4, so we're just going to have 2 multiplied by 4, that is an 8. Okay, so what then do we have on top? Okay, so what we have, so we've got the 4a, a is 4, c is, we're saying it is negative 1, negative q. Okay, so we're going to have 16 positive or minus the square root of 256 minus 4ac. Okay, a, we're saying it is 4, then 4 multiplied by 4, then the c, it is a negative 1. We're going to have 144 there. Okay, plus actually over 8. Now we're going to have 16 positive or minus the square root of 256 plus 144. I'm going to have 400 over 8. Okay, so for quadratics, I really don't like solving quadratics, but still we are going to solve it. Okay, so 16 positive or minus the square root of 400, that is a 20, okay, over 8. Now 16 plus 20. Okay, so those are the values of u. Okay, u is equals to that and that. So if the first u is equals to, so in this case, what are the values of u? U will be equals to 16 plus 20 divided by 8. 16 plus 20, that is 36. 36 divided by 8, so we're going to have 36 divided by 8. Okay, we can look for two numbers that can go into 36, and the 2 can do that. Okay, actually 4. 4 into 36 is a 9. 4 into 8, that is a 2. Okay, that's the first value of u. Another value of u is where u is minus 16 minus 20. That 16 minus 20 divided by 8. 16 minus 20, that is a negative 4 over 8. So u will be equals to, if we simplify it further, a 4 into a negative 4, that would be negative 1. A 4 into 8, that is a 2. So those are the value. There are two values of u. Now you have to remember that we have to replace we have to make our equation to be u. Okay, since we said that u is equals to p squared, so if u is equals to p squared, we are going to square all our answers. So in this case, our u, the first value of u, we had 9 over 2. So I'm going to square this. Okay, this is equals to p, like that. Okay, so what we are saying, if we're trying to find p, we're going to square root on both sides. Okay, so that we find that the square and the root cancel, and then we find the value of p. Because we're not finding u, we're finding the value of p. So p will be equals to the square root of u. The first u that we found, it is 9 over 2. So 9 over 2. Then the other u that we found, in this case p will be equals to the square root of the other u, it's negative 1 over 2. So now the square root of 9, that is a 3 over root 2. That is the first p. Then the other p is the square root of we're going to have the square root of negative 1 over 2. We're going to ignore that one because it's a complex number. It's a very, very big number. So we're going to still say, it's going to give us like I over root 2. Okay, we can just write it for the sake. Now we are going to go back to our equations. So this one, 2pi is equals to 3I. Okay, we know what p is now. We're just supposed to replace. So if one value of p is this, positive or minus, actually since it was a square root here, we're supposed to have positive or minus. Okay, so now we're just supposed to now solve and replace in that to find the value of q. We already have p. So here, what are we going to do? We are saying the equation is 2p q is equals to 3. Then if p is equals to, let's say we start with the positive one from here, what are we going to have? So we're going to have 2, 3, then we've got, let's say, divided by root 2 is equals to 3. Okay, then we solve that part. Okay, we solve that part. What then are we going to have? Okay, since we're finding the value of q, I think this one is going to confuse us. Let's make q the subject of the formula in advance. So q will be equals to 3 over 2p. Okay, so in this case it will be 3 over 2 multiplied by our p. Our p is 3 over root 2. Okay, I think this one now is better. So from there, you're just supposed to now solve this expression. Okay, so in this case, your 2 multiplied by your 3 there, it is a 6. So I have a situation where I've got a 3 over 6 over root 2. So you know that this is just going to be 3 divided by, okay, let me just wrap this part. You know that this is going to give us 3 divided by 6 over root 2. But this is because we're dividing, we're going to swap. I'm going to have root 2 on top over 6. Then we're going to change the sign. Then 3 into 3 is 1. 3 into 6, that is 2. So our answer, it is 2 root 2. That is the first value of q. Okay. Then you also have to try when you have the negative answer now. So when you have the negative answer, the negative part, we are saying q is equals to 3 over 2 over 2p actually, yeah. So in this case, we've got 3 divided by 2. Then our p is the one that has let's say now this time around you get the negative one. Okay, then you just solve. So what then are we going to have? Because this time we've only changed the negative, so another value of p is just going to be another value of q will just be equals to negative whatever we had at first, but this time it's just going to have a negative. So those will be the 2 answers that we are going to have. So basically that, not very complicated. Then we come to question number 10. If that and that where x and y are real numbers, so for x and y. So these are other equations that we are solving. So let's first expand this expression that we have. We're going to have 2 multiply with everything that we have in the brackets. So let me just do it in advance. 2 multiplied by 3x, that is 6x, plus 2 multiplied by I, that is 2i, negative I y multiplied by 3x, we're going to have negative 3x I y I, then negative I y multiplied by I, we're going to have, if we do it in advance, we're just going to have positive y squared, because I squared is negative 1. Then here, what do we now do? Is there anything that we can simplify here? Okay, no. Okay, now that it's in this form, we have to make sure that we put the real parts alone and the image part alone, the ones with I alone and the ones with which are not I alone. Okay, so in this case, what do we do? So for the real part, we've got 6x plus y squared. Okay, where am I even getting the y squared there? Okay, this is just y. Okay, this is just y, it's not squared. Okay, so we've got this part, this is the real part, then the image part we've got 2y, then the other one it is negative 3x y, then there's also I, this one. Okay, so for this one I can simplify it, the I, because it's common on both sides, I can factorize, so I'm going to have 2 minus 3xy, then I put the I outside. Okay, so basically that. Now this whole expression, so we've got the image, this is the real part, this is the image part. These two, when we solve them, they're giving us this expression. So in this case, when we solve the real part, it's giving us this part. When we solve the imaginary part, it's giving us that part. That's what it means. So in this case, the 6x plus y should give us a 2. Then the other one, the 2 minus 3xy should give us a 3. That's what it means. So I can just solve this one. Negative 3xy will be equals to, when I take the 2 to the other side, it's going to be 3 minus 2, which will give us a 1. Then here, I'm going to divide by negative 3 on both sides. So our xy is just equals to 1 over negative, this is negative 1 over 3. Okay, so that is that part. Then we can also get this other one simplified. Let's make y the subject of the formula. Y will be equals to 2 minus 6x. If y is equals to that, we can replace where y is there. We're going to have, let me just write it on top, xy is equals to negative 1 over 3. Okay, so when I replace where y is there, we're saying it is x, where there's y it is 2 minus 6x is equals to negative 1 over 3. Then I'm going to have 2x minus 6x squared is equals to negative 1 over 3. Okay, now what I'm going to do, I'm just going to multiply by 3 on both sides throughout, because I don't want fractions. So I'm going to have 6x minus 18x squared minus is equals to the negative 3 and negative 3 I'm going to cancel on the other side. I'm just going to have a negative 1, which is what I wanted. Then we're going to have 6x minus 18x squared. Okay, 18x squared. Okay, let me just do the opposite. I'm going to take these expressions to the other side. Okay, so when I take the negative 18 is going to become 18. It's going to become positive, so positive 18 squared. Then I'm going to have negative 6x. Then I'm going to have negative 1. Yes, so this one is written in a nice form. Then from there, now you're just supposed to now use you're supposed to solve this using the formula method. Okay, the formula method, the quadratic. So in this case, x will just be equals to positive or minus. So positive, no, negative b. Negative b in this case, our b is 6, is negative 6. So we're going to have 6 positive or minus the square root of b squared, that is 6 squared, that is 36. Then minus 4 ac, 4. Our a is 18. Our c it is a negative 1. Okay, so 4 multiplied by 18, that is 72. Now there's a negative there, so we're just going to have a positive 72 there. So positive 72 over 2a. Our a is 18. Now 2 multiplied by 18, that is 36. Okay, basically this. Then we just we say x is equals to 6 positive or minus the square root of 36 plus 72. That gives us 108 over 36. Okay, that is what we have. X will be equals to, okay, so I just allow me to rub which part, even this side. Okay, so our x in this case is just going to be 6 positive or minus 108. The square root of 108 is going to be 6 root 3. Yeah, 6 root 3, because it's going to be 36 multiplied by 3. 36, the square root of 36 is 6. Then divided by 36. Okay, now that we've got this, we know what this means. I can simplify it further. X will be equals to 6 into 6 is 1, positive or minus 6 root 3. Then 6 into 36, what am I going to have? So I'm literally dividing everything by 6 to simplify it further. 6 into 6, so 6 into the first 6 is 1. Then 6 into the other one, it is also 1. So I'm going to have root 3 there. Then 6 into the 36 there, I'm going to have 6. Okay, that I would have, by doing that, I've multiplied by, I've divided by 3 by 6 everywhere. Okay, now what do we now do? If I solve this one completely, what am I going to have? If I cross multiply, I'm going to have 6x is equals to 1 positive or minus the square root of 3. So that is what we have. Now we're saying why is that? Okay, y it is 2 minus 6x. So if y is equals to 2 minus 6x, so I'm going to have 2 minus 6x. Now the 6x in this case, what are we getting? X is equals to 1 plus the square root of 3. So I'm just going to replace there and you solve. Y is equals to 6 minus so I'm going to start with the first one, 1 plus the square root of 3, then there's a 6 there. Okay, so I've gotten one of them. So the 6 and the 6 are going to divide. Okay, so I'm going to have y is equals to 2 minus, I'm going to have 1 plus root 3. Then from there I'm just supposed to now say y, in this case it's going to be 2 minus 1 minus root 3. Then if I solve that, y will be equals to 2 minus 1, that is a 1. So we're going to 1 minus root 3. Okay, so that is the value of y. So y is equals to 1 minus root 3. That's the first value of y. The second value of y, since this time around now we are considering a negative, so it means our answer, the second value of y is just going to be positive. Y is going to be 1 plus root 3. So those are the answers for these our expressions. So for us to write them nicely, let's just write them nicely. So we've got x and y as a point. Okay, so this is equals to, the first one we said it is 1. If we're going to start with the minus 1 over 6, the answer that we got, it is 1 minus root 3, which is that one for y. Then again we have another set of answers for x and y. This time around we got 1 minus root 3 over 6. Okay, or actually the other one is positive. We started with the positive one, this one was positive. So this one, the negative one, will give us 1 plus root 3. So basically those are the answers for this one. Okay, now we come to question number 11. If z is a complex number such that that and is equals to that, find the value of the modulus of z. Okay, so you can let z to be anything, then you just solve. Okay, so we can let let's say let z we let z to be, let's say, x plus y, x, y and I, because you know that these are complex numbers, so you can have an imaginary a real part and an imaginary part. Okay, so let's solve the first one. We've got 7, we've got z plus 4i. Okay, z plus 4i is equals to, now if we solve this, okay, if we solve, we've said z, we've let z to be this. Okay, so wherever there is z, we're going to replace that. So this is an equation, so I'm going to have the modulus of, so z, it is x plus y I. Okay, then there's also plus the 4i there. Okay, now in this case I'm going to have the modulus of x plus what, x plus, now I'm able to see that this has I and this has I, so it means I'm supposed to factorize the I. So I'm going to have y plus 4i because they both have I. Then from there, if you're finding now the modulus, because these, the absolute bars, they're just telling us to find the magnitude. So in this case, what are we going to do? The magnitude, you find it by x squared plus what you have as the image, which is y plus 4 squared, like that. Okay, so that is the first part on the other side. That is our z plus I. Now, how is our equation now going to become? what does our equation become? X squared y plus we've got y plus 4. Okay, so this is the first part. Then we equate to the other one, 2 z. What have we found as z? Z, we are saying it is x squared, the modulus of z and I. So in this case, what are we going to have? We're going to have zx. Okay, let me just put it in advance. We do some magic here. So this is 4i. This is 4i. This side we only have I. Okay, then when we solve the z, here we have a 4. So it means on the other side, because we have I, we're just going to have an I squared. Okay, in the same expression of the magnitude, because even here we're finding the magnitude. Okay, so instead I'm going to put the magnitude in advance. Then we know what z is. Okay, z it is x squared plus y plus I, because here there is I. Okay, so in this case I'm going to have I squared is just a, in this case it's going to be what? A negative 1. So in this case we're going to have 1, that's the coefficient there, then we square it like that. Okay, now that we have this, what do we now do? We can now square on both sides to remove the roots. Okay, when we square on both sides, we're just going to have x squared plus y plus 4 squared is equals to, because we've squared on both sides, we're going to have 4 here. Okay, for the 2 that is there. Okay, then the root is the one that's just going to cancel. For the other one, we're going to have x squared plus y plus 1, then we have a square there. Okay, so now what do we now do? We just need to solve the ones that are in the bracket. So we have x squared plus, when we solve this one, what is going to be? We're going to have y squared plus 8y plus 16 is equals to, we come to the other side, 4, then we're going to have x squared plus, we're going to have, when I solve what is in the bracket, I'm going to have that is 2y. Okay, when I solve what is in the bracket, okay, let me just even distribute it in advance. A 4 multiplied by x, I'm going to have 4x squared plus the 4 in front. Okay, the 4 in front, so I'm going to have 4, the y is going to be squared, so it will be y squared, and then plus, I'm going to have 80y. Why? Because we're going to have a 2 there, and then plus the 1 squared is 1, multiplied by the 4, I'm going to have a 4. Okay, basically that. Then what do? We can cancel the 8y on both sides. 8y and 8y can divide. Okay, so let's just now check what we now have. Okay, so now we have x squared plus y squared plus 16 is equals to 4x squared plus 4y squared plus a 4. Okay, now what can we now do from here? Okay, what can we do? We've got xy 16. What can we, let's say if we take the 4 on the other side, what are we going to have? We take this 4 on the other side, we're going to have 16 minus a 4. 16 minus a 4. So I'm going to have x squared. This is also 4x squared. I'm going to take it to the other side where there's x squared. So I'm going to have negative 4x squared plus y squared I'm going to have negative 4y squared is equals to, if I've got a 4 there, I take the 16 to the other side, I'm going to have negative 16. Okay, now that I've got this, I can now solve negative x squared minus 4x squared. I'm just going to have what? Is it negative 3x squared? Then the other one, I'm going to have negative 3y squared is equals to negative 12. Okay, negative 12. Now what do we do? Because they are negatives throughout, I can multiply throughout by negative to just to avoid negative. So I'm going to have 3x squared plus 3y squared is equals to 12. Okay, now that I've got this, what then do I do? Okay, so now here what we now do is I can divide by 3 throughout again. So when I divide by 1 over 3 actually, so I'm just going to have x squared plus y squared is equals to 12 divided by 3, that is a 4. Okay, so x squared plus x squared plus y squared, it's giving us a 4. Okay, now so you're able to see that what did we say? Okay, now I tried to find the value of the modulus of z. Okay, find the value of the modulus of z. So in this case, if z squared, because these are squared, z, the modulus of z squared is giving us what is giving us a 4. Okay, this 4 is coming from x squared plus y squared. What about just z alone? So z alone will just give us a 2. So basically that. Then we come to the last question in this tutorial sheet. Let z to be that. Find a plus a and ib if that is that. Okay, so you can let the same expression. So we're going to let z to be a plus ib. That's what they've told us. Then we've been given 2 plus ib is equals to that. So we've been given 2 plus 3i. Then there's a z is equals to 7 plus I. Okay, so we're supposed to find what A and IB are. Okay, so what then are we supposed to do? Well, let's replace where Z is. So we're going to have 2 plus 3I. We've been given Z here, and Z we've been told that it is A plus IB. So I'm going to replace it where I'm going to replace it here. A plus IB is equals to 7 plus I. Then you know that we're supposed to expand this way expression. Okay, so if I expand this way expression, what am I going to get? I'm going to get 2a plus 2ib plus 3ia plus 3i squared b is equals to 7 plus what? 7 plus I. Okay, now if I simplify it even further, what do I now have? I'm going to have 2a plus the ones with I, I'm going to put them together in one bracket. We only have this one and this one. This one is going to give us a negative. It's not part of that. So in this case, what are we going to have? I'm going to have the I outside, then whatever remains I'm going to put in brackets. I'm going to remain with 2b plus 3a. Okay, Then the other one we've said is going to give us negative. So the I squared is -1, so it's -3b. This way expression is 7 plus I. Okay. Now that we've got this, what then do? We're just supposed to equate the real part and the imaginary part. But of course, the real parts, we've got 2a minus 3b. Okay. Then the one with IB is going to also be alone, which is 2b plus 3a is equals to 7 plus I. So that is what we have for now. We can just rub this part and use it for solving. Okay. So now what do? Let's now equate. We are going to have 2a minus 3b is equals to -1 actually. Okay. No, actually it's 7. Hey. So this is 7. Then from there, what do we now do? We're just now supposed to like solve. If I make okay, I think there's nothing much. This one is not going to help us so much. We're going to go to the other one. The other one is what? Okay, 2a. Okay, let's try to make any of the subject to the formula. So I can have 2a is equals to 7 plus 3b. Okay, then if I divide by 2 on both sides, our a is equals to 7 plus 3b over 2. Okay, so if we've got that, where are we now going to use this one? So the other expression is this one. The imaginary part, they are giving us 2b plus 2b plus 3a is equals to 1. Okay, if they are giving us that, and we found that a is that, so I'm going to have 2b to be then plus 3. Our a, we are saying it is 7 plus 3b over 2 is equals to 1. It's equals, a is equals to that. We're just from finding that. Then now we're just supposed to just like solve. In this case, for me, I'm going to multiply throughout by 2 because I don't want fractions. So I'm going to have 4. I'm going to have what? Is it 4b there? Okay, 2b. Yes, so I'm going to have a 4b there plus is what? Okay, so that is going to give us what? Yeah, that one. So I'm going to have a 3 multiplied by, because a 2 and a 2 are going to cancel. Then I'm going to have a 3 multiplied by everything that I have in the brackets. So a 3 multiplied by 7, that is a 21, plus a 3 multiplied by 3b, I'm going to have 9b. This will be equals to 2. Okay, now that I've got this, I can put now the like terms together. 4b plus 9b. Okay, I'm going to have 13b. Then there is plus 21 there is equals to 2. I'm just supposed to put the like terms. 13b is equals to 2 minus 21. So 13b in this case will be equals to 2 minus 21. That gives me a negative 19. Then I'm going to divide by 13 on both sides. So therefore my b will just be negative 19 over 13. So that is my b. So now how do I then find a? Okay, because we've been asked to find a and b. So a is even here. A is equals to 7 plus 3. Our b, we found that is negative 19 over 13 over 2. Okay, then from there we just solve. So allow me to rub this part. Okay, so therefore a will just be equals to 7 plus so I can now multiply 3 multiplied by negative 19 I'm going to have negative 57 over 13. Then there's a 2 there. Okay, then what do we then do? So when we solve what we have on top, what are we going to have? We're going to have 91 minus 57 over 13 divided by a 2. Okay, then 91 minus 57, that will give us 34 over 13. The division is going to become multiplication. I'm going to have 1 over 2. Then what do I now have? 34 over what is this? A 2 multiplied by, that is a 26. Okay, then I can now reduce this one further. What do I then have? A 2 into 37, that is a 17. Okay, a 2 into 26, that is a 13. Okay, so I'm finding my B to be, my A to be 17 over 13. Okay, so then what is my final answer? That is the question. So okay, let's just now. So we found that A is equals to 17 over 13, and B, we have to find that it was negative 19 over 13. So therefore Z in this case is just going to be it's A, which is its root part. We're going to have 17 over 13, and then minus 19 over 13. This is the image part of it. So basically this is how we solve questions in this tutorial sheet. So thank you for watching to the end. We're going to see you in other sessions.